Hello, this is Christian, the author of AutoSpotting, cloud computing optimization software. And today I'm going to show you what AutoSpotting is and how to install it in your Amazon account. So AutoSpotting works by replacing existing instances in your auto-scaling group with spot instances. So the way it does it, whenever you launch a new instance, there will be a component that listens to that launch event and replaces that instance with a much more cost-effective spot instance. So without further ado, let's get started and install AutoSpotting. So the way you install AutoSpotting is to the AWS console and just searching for it. So you search for it, it finds it in the marketplace, and essentially you just have to follow the usual installation process for a marketplace product. So you have to continue to subscribe, continue to configuration, and continue to launch. Once it's shown in this view, essentially you have three different options. You can download the CloudFormation template to run it yourself. There is a Terraform module if you want to use Terraform for it. And there's also a CloudFormation quick installation. So I'm going to follow this quick installation because it's the most seamless option that we have. You just have to click a few buttons and you have it installed in your account. The others are good if you're using infrastructure as code, but in this demo, I'm just going to run it with a few clicks. So the way it works is it takes a CloudFormation template and it will create a stack out of it. The template is pre-populated when you click that link. So you just have to click next. We can give it a name, AutoSpotting. I'm going to briefly describe these configuration options. Most of them you don't need to care about. People usually I've seen mainly work with the disallowed instance types, which allows you to select some instance types that you don't want to be used in your configuration. For example, it sometimes is not desired to run maybe unburstable T2 instance types, because those instance types have these credit-based system, and what happens is if you're running out of credits, those instances will get throttled. So let's say you want that to be disabled. So I'm just going to add this to the list. Most other options aren't really supposed to be fiddled with. You can still tweak with a few of them. So for example, the EBS bandwidth, there are instance types where the bandwidth is higher than other instance types, and if you have an instance type with higher bandwidth and you expect that bandwidth to be enforced on all the other instance types, basically you can enforce it here. So you can set it to true, and then the way it works, you will only get instance types with as much bandwidth. Most of the people leave this to false, and that's recommended because it improves the diversification for your configuration. And in case of spot instances, diversification is very important for getting the capacity. Other things notable are this event-based instance replacement. The way this works is it's reacting earlier than the terminations, but we have seen this to cause increased interruption rate. So that's why we recommend it to be kept at false. We talked about the disallowed instance types. And yeah, we have the execution frequency for, like, the way it works. If you deploy AutoSpotting on an existing group that has running instances, the way it works is it will pick one of those instances every 30 minutes in this case, and it will terminate one of them from the group, and giving the chance of AutoSpotting to replace it with a spot instance. And you can increase the rate of interruptions by tweaking this. We leave it at 30 minutes because that's a typically safe value. Now, this filter by tags flag controls whether you're using the default tag. So the default is spot enabled. It has to be set to true. But you can still also pass other tags that you may have in your account. So if you leave it empty, it will just take the default. Otherwise, you can run it against existing groups that have already a tagging convention. So I'll just leave it as empty. GP2 conversion threshold, that's a feature. It's supposed to work with EBS volumes. And in case of EBS volumes, AutoSpotting tries in most situations to provision volumes with the GP3 volume type if you had a GP2 volume type. And below this 170 gigs, GP3 will always be cheaper by 20% and faster than GP2. And over this, GP2 grows performance by size. So every gigabyte, you get 3 additional IOPS, if I'm not mistaken. So by a terabyte, the GP3 and GP2 will have the same performance out of the box. But this is a feature that keeps that conversion under control for smaller volumes. It doesn't always work because these volumes come from different places in the configuration. So they may be set in the AMI, they may be set in the launch templates, they may be set in the launch configuration. And AutoSpotting covers a few of those places, but it doesn't cover all of them. And for that, I have a second tool, EBS Optimizer, which works on the volumes themselves, regardless how they were provisioned. And I'm going to demo that in a different video. But the way it works so far is if volumes are set in the launch template and launch configuration, AutoSpotting will try to convert them. There are a few other things related to like how it's handled the termination. I would leave it as default here, so it's not recommended to change. Also, the other things are like how we tag the functions that we deploy in the account. Because AutoSpotting runs with Lambda, it's implemented in a Lambda function, you can tag it. You can also set the memory size. We have some logging retention that we can control. And also many customers use different settings for the number of on-demand instances that they want to keep in their account, in their groups. In the default configuration, everything is replaced with Spot. But many people do have reserved instances that maybe they want to, they are paying for them already, and they want to keep at least, let's say, maybe 2 instances in each group to be the baseline capacity as reserved instances. So AutoSpotting will not touch those. But if you set it to 2, for example, in here, and then the group grows, additional instances would be replaced with Spot. So this is a good model for covering a baseline with on-demand, with reserved or instances or savings plans, but then using Spot on top of that baseline. And that can be configured as a number, but also could be configured as a percentage. So if you set it as a number, this is fixed across the configuration. And this also can be overridden with a tag that you can tag at any given auto-scaling group to override this value. The percentage would be useful in case you want, for example, to roll out AutoSpotting at a larger scale. In particular, with another flag we have here, which is the opt-out model. So if you use opt-out, AutoSpotting will work on all the auto-scaling groups from the account unless they are configured with spot enabled equal false. So for that case, if you combine that with the percentage, you can make AutoSpotting deploy spot instances on, let's say, all your groups for, let's say, 40%. Let's say if you set it here for 60%, it will keep 60% as on demand, but then the next 40% would be replaced with spot. And that's a nice way to roll out spot at any scale within your organization. Chances are, if you disrupt the groups by less than half of the capacity, the groups will keep running and you will get reduced costs. And you can actually combine these. So you can set here a 2 and a 60%. And if you have a group with like just 2 instances, the largest value will be kept. So if you have 2 instances will be kept. If you have 3, then at some point the percentage will become higher, and then it will start replacing instances. So that's how it works. The next flag we have is on-demand price multiplier. So I'm going to revert this to 0 for the sake of our demo. The on-demand price multiplier is able to configure the hourly price that you want to have for your on-demand instances, for your spot instances. So when you launch a spot instance, the way it works, it's selecting the instance having as much capacity or size as the initial instance. So if your initial instance had 2 CPU cores and 4 gigs of memory, it will replace it with instances as large, at least as that one. But it will not go over instances that cost more than the initial on-demand price. So let's say if your initial instance costed $1 per hour, the replacement instances will never be more expensive on the spot market as the $1 an hour. So we have like a window of compatible instance types that you can get for a given instance. And with this flag, you can control, you can multiply this on-demand price with a factor, and you can set it like, say, 0.6. And the way it works with setting it like this, it will consider, instead of $1 an hour, it will consider 60 cents an hour as the cutover price. And what's useful is what this is useful for is in case you're having savings plans or reserved instances for your capacity that cost around 60% of your on-demand price. So that will allow your spot instances to always be provisioned under this price, coming from the, like, multiplying this with the on-demand price. So you will not get instances that are more expensive than your reserved or savings plans. We also have, so I'll keep this to 1. We also have a way to tweak in case it's a elastic beanstalk environment. So there are a few configurations when it comes to the CloudFormation authentication, and we are patching actually the user data in those cases. So if you're using beanstalk, you may want to set this to true, and it's adding a few lines at the end of the user data script. The next flag is about prioritizing instance types. So here we have 2 options. You can have the lowest price, and in this case, it will just take instance types and order them by the price. And when you get the spot instances, essentially we call an API, and it will go over this list and launch the cheapest one that's available without significant interruptions. And basically, we could also have it by the next value is newer generations. And the way this works, it's penalizing older generations so that your instances will be preferred from the new generation. And the way it works, we just add a 10% for each older generation. So let's say we have C6i, which is the latest generation on Intel, and we have C5, and then if they are at the same price on the spot market, what we do is when we compare them, we add a 10% to the C5 to make the C4 to make the C6i preferred, and this gives us a way to prefer for newer generations, which are usually more performant, even if they are at the same price. You may want to run them. And this is particularly useful for cases like the Graviton, where we have C7i, and that C7i is more expensive typically than the C6i. So the Amazon adds like 7% on top to the price of the C6i, but the performance you get from the C7i is at least 25% more. So if you prefer newer generations and you run a Graviton instance, you will get the C7G, and the C7G will be faster than the C6G. Sorry. Yeah. The next flag is setting a list of regions, and here we default by running on all regions. Many customers just reduce this list to a smaller set of regions where they may have instances running. Otherwise, AutoSpotting will connect all the time to those regions and will listen for events in those regions and so on, which may cause a bit of network traffic within your account. So people sometimes just leave one or two regions where they are running in. The next things are not supposed to be changed. So we have the SKU that we use for shipping events between invocations of the Lambda functions and serializing them, and we shouldn't touch that. Then the next few flags are about the source of the Docker image. The way it works, we run Lambda with a Docker image, and that Docker image comes from the AWS Marketplace by default. And this ECR is the ECR of the marketplace. And this is our image and the version of our image. And this is the latest version we have. The next flag is the spot allocation strategy. So when you're getting the spot instances, we have three ways to get the capacity. The first typically was lowest price, and with lowest price, it does exactly what it says. So it orders instances by price and always launches from the cheapest one. And the problem with this is that cheapest instance at times may not have enough capacity, or it may be in a state of flux that it keeps launching or terminating instances. So this could cause a lot of interruptions at times, but it's good if you don't care about the interruptions. So you may still run it if you don't care. But if you do care about interruptions, you may want to use one of those capacity optimized alternatives. So the plain capacity optimized will not look at the price at all, and it will just look at the amount of capacity that AWS has in the availability zone. So it takes all those instance types that we have selected, and it will just launch the one from the biggest capacity pool. And that at times could be very far from the cheapest instance type that we have. So if the range is from the initial instance type until a type that has its on-demand price, chances are at times it will select like something that's running at like 80 or 90% of the on-demand price. And you may not want to do that, even though this will optimize heavily for reduced interruptions. And what we have is a mix of these, and the default comes the capacity optimized prioritized. And what we do here is we order the instance types by price, considering maybe this bias for newer generations that I mentioned earlier. But then when you launch the API call, it will skip them if they have high interruption likelihood. So this will essentially give us the cheapest instance that will not be interrupted in the foreseeable future, or at least in the near future. And this is a good balance between cost and stability of your capacity. There's also the next flag is the percentage buffer. So for this, there is a way for us to set the price based on the current spot price and the buffer, but this is only used when using one of the other flags, which is this bidding policy. So this bidding policy, the normal one is just setting the on-demand price, but you can do the aggressive one, and then the aggressive one will consider the current price plus a percentage on top of it. And this is where you control that percentage. And that was useful before when we had instances with the spot prices fluctuating a lot, but this is no longer so relevant now that spot prices are relatively stable. So this is not so relevant anymore. Spot prices increase, but very slowly. Then we keep it for next one is the product. So we keep it for Linux. There's also a premium, and this premium hourly price is in case you're running something like Red Hat Linux or SUSE Linux, which have a price premium on top of the spot price, and that you can configure here if you're using that as a Red Hat or SUSE, but we will just keep the default. And this premium will be added to the spot price and on-demand price to consider that difference in operating systems. I already talked a bit about the filtering mode, which is opt-in or opt-out. So I'll keep it to opt-in, which is the default, which requires the spot enabled tag to be set to true on your auto-scaling groups. But if you're brave, or if you're running it with a certain configuration, you can always use it in opt-out mode later on. Then we have also a termination notification. So this has to do with what do we do when terminations come, and basically the auto will handle it based on the lifecycle hook, or else it will just detach the instance if there are no lifecycle hook, and then it will leave the termination to take place. And then it's also, if you do terminate, we terminate it ourselves, which will trigger the lifecycle hook, or we could just do detach. So auto is a mix of them, and we keep it like that. So yeah, this was a walkthrough to all the configuration options. To recap, the ones that you care about most usually is the list of instance types that you disallow. You may want to change the on-demand numbers or percentages, may want to change the multiplier, and may want to play with like the newer generations or the lowest price. Yeah, but essentially the defaults are pretty good. So I'll just keep most of them as default. I'm just looking again to make sure nothing is changed without me needing to change anything. Yeah. So I didn't talk about this one. The allowed instance types, you can keep it empty. If you keep it empty, it will take anything. If you force it to certain values, only those will be allowed. So I would recommend to use a mix of this with the disallowed instance types, and the whichever, like, allowed take precedence over disallowed, if I remember correctly. So if you notice any conflicts and anything weird, just make sure there are no overlaps between them. Okay, so now let's go and launch this template. And it's essentially a matter of just clicking next a couple more times. And yeah, AutoSpotting is now creating in the account. So it will create a bunch of resources. And you can wait. It takes about 3 minutes for it to finish. And yeah, I'm gonna stop here in this video. I'm gonna create another video with how you run it and how you test it in your account. So that's it for now. See you later.